Hello and a very warm welcome to this webinar, where we'll learn how connectivity innovation in servo drives is making integration faster and easier. I'm Simon Fletcher, I'm hosting the session. I'm pleased to introduce a couple of my colleagues, Josh and Johan. Both are product marketing managers for electrical automation at Festo. Josh has worked his entire career in industrial automation with a focus on servo drives and control solutions. Johan has over 30 years industrial automation experience and has an extensive knowledge of servo drive technology and electric automation application solutions. They're going to show you how easy and fast Festo servo drives can be integrated into virtually all control systems. So you can interact with us during the webinar. If you have questions, type them in the question box, which you can access from the GoToWebinar menu. We'll stay online at the end of the main presentation to answer your questions, and if we don't get to any, we will answer them via email. We also have a couple of polls for you to participate in, where you can share your thoughts with the presenters and the audience. So that's enough of an introduction. I'm going to hand over to Johan, who's going to be presenting the main presentation.
So thank you, Simon, for this nice introduction. Now, Josh, what are the main challenges that machine builders are faced with today with regards to servo drive technology?
Thank you for the question there, Johan. So when we're talking about challenges today, behind me we've got a number of challenges which we believe are challenges when integrating servo technology. Some of these are with regards to training and support, making sure you are fully trained and supported on any of the software tools, which could be new and unknown. And with any new and unknown software, you need time to familiarize yourself. Make sure you are fully familiar and you know how to use those software. And then with any servo drive technology, you've got the cost of the goods, but then there may also be cost of software or even cost of licenses to contend with. These all add into the risk of the changeover. And then finally, PLC compatibility. A number of machine builders may need to integrate different PLCs based on the end user specification. So with this, compatibility becomes one of the main challenges when integrating servo technology. And finally, something we're all dealing with currently at the moment is delivery and supply chain issues. Based on the project, the timeline of the project and the scope, these may be a challenge when integrating the servo drive technology. So we just went over what Festo believes some of the main challenges are in integrating servo drives. But now we really want to get some of your feedback with a quick poll. So I'm going to hand over to Simon to take us through the first poll.
Okay, thank you, Josh. So the first poll is, what are your biggest challenges with integrating a servo system? So you can select all of these that apply: integration of servo drives to PLCs, parameterization of your servo drive, sizing of mechanics, sizing of motor and gearbox, and mechanical connectivity between components. So I can see, Josh, people are just voting. We'll just give them a few seconds just to let everyone put their choices forward. Okay, looks like a good spread. Okay, just 5 more seconds and we'll take a look at those results. Okay, Josh, so interesting set of results. They all got some votes from the viewers. The top one here is integration of servo drives to the PLC, followed by parameterization of servo drives.
No, that's some really interesting feedback, that these will to help guide us really on integration of servo drives to PLC and parameterizing the servo drives. These are a couple of topics that we're going to be running through on this webinar series, so we'll focus a little bit more time in these areas. But thank you very much for your feedback.
Yeah, very interesting to see the feedback of our audience. Thank you for that. Now, Josh, how can we support our customers in removing the risk when integrating servo systems into their machines?
Okay, thank you for that, Johan. So Festo have a standard process that we like to go through, and it's kind of 3 steps which we're going to talk through now. And the first one is actually securely selecting servo systems based on application data. This is a really, really important first step because you don't want to be oversizing the servo solution, that you've paid for product features which you don't actually need for your application. But at the same time, undersizing a servo system may mean that it's not suitable for the application. We then need to take the next step as faster, easier to build, design, and commission a solution. You want to make sure this is seamless, that it integrates both mechanically, electrically, and from the PLC side of it, which you gave us some feedback on, which we'll spend a bit of time on later, but also reducing the time and cost and any associated technical risk. And with all of this, through each stage that we go through, we're always talking about peace of mind. And we'll talk about how we provide peace of mind through each stage of the application, making sure that your servos are sized, selected, commissioned, and mechanically installed to be the right solution for you. So I'm going to talk about a standard application, Cartesian-based solutions, and really that first stage, how we securely size the best possible solution. So for this image here, we've got a Cartesian-based solution. So 3-axis. Now, if we just take one of those axes and we take it as a traditional process of how we may size this. So the first thing we need to consider is what the payload is. So we've got the payload and we know how fast we need to move from position A to position B. So you start to take a look at the technology you wish to utilize. Do you wish to utilize a ball screw, a tooth belt? So you've sized your ball screw, your tooth belt to move your load from position A to B in your defined time parameters. Now, once we've done that, the next thing we need to take a look at is the guidance. So you may use a separate tool or software to size the external guidance because you may have an offset load. So we now know that we're going to utilize potentially a tooth belt axis. We'll have to take a look at the guidance, but now we need to take a look at, for instance, the gearbox. There could be a different piece of software for sizing the gearbox, for the torque input, and then the motor and controller associated with that. So to size a single axis as part of a 3-axis Cartesian solution, you may have put several hours in, use 3 or 4 different softwares, which you may all need to incorporate to one another. Plus, if you change a single parameter in that whole entire process, you will need to start from the beginning again. So there must be a better way of performing this. So what would that piece of software look like? Well, you would need a piece of software which would do all of the technical calculations for you from your application parameters. It will produce multiple solutions. There's never a single solution which is suitable for an application. You know the parameters and you'll need to evaluate these. Creates a full BOM. You're not looking at different parts of the BOM, single tool with all the components necessary for that mechanical axis. It produces a detailed report for the sizing, which you can store into all of your technical documentation for the application. And finally, the most interesting part is, could it create a parameter file? So the application details which you utilized in sizing it were then put directly into the parameterization of the drive. And that's one of the things which you gave us some feedback on in terms of what could be one of the biggest challenges. So this tool could look like the Festo electric motion sizing tool. And I've actually got a live example here, which I'm going to run through. An electric motion sizing tool is actually integrated directly on the Festo website. So when you open this up in the website, you've got 3 different options. The first option is the multi-axis handling. This is our handling guide online, a single tool to design and size a 3-axis Cartesian solution or 2-axis. We've then got our rotary movement tool. So with this option here, if you're going to size, say, a conveyor or an indexing table, you can utilize this section to put in your application parameters. And finally, we can then take a look at linear movements. Now, there's many linear movements you can select, as we've shown here: 2 positions, pressing, Z-axis, multi-position systems. So you need to select the one most suitable to the application you wish to size, find it, and then we can specify the parameters. So now we open it up, 2-position handling, and now we go through the basic parameters. The first one is, well, what is your stroke length? How far do you need to move from A to B? We've got the options of both a slider to move it along, but also we can overwrite that to find the actual stroke length. For instance, 550 millimeters or 500 millimeters. We can then take a look at our mounting position. Is the axis need to be horizontal, vertical? And if you're not sure, there's an I button we can select to define what those criteria are. We can have a payload. So let's input 5.5 kilograms. And once we've got these base parameters and we've got the payload, what is the offset of that payload relative to our carriage? So in this, again, select the I, see the planes in question, the X, Y, and Z coordinates relative to the actual carriage, and define these. So for the purpose of this, let's put 100 mil in our X, 100 mil on our Y, and 0 mil on our Z. Now we've done these, the next parameter we need to specify is our traveling time. How quickly do we wish to move from point A to point B? So for purpose of this, we'll put in an arbitrary value, but also, do we have the payload going there and back? Is it a pick and place? We can define this to make sure we optimally size the motor and also our dwell times. And finally, what field bus do we wish to utilize? EtherCAT, Profinet, and what type of axes? Now we've done all this, the next stage is to select continue, and we can start to then see what these results are. And it will live update and provide us the 3 most cost-effective solutions, which I will scroll down now. Now you'll take a look at these, and when we go back up to the top, we'll see how the tool breaks it down, not just in terms of servo drive usage, the motor usage in terms of current and the workload, but more importantly, our mechanical axes. It'll break this down not only into the actuator percentage workload, but also the guidance. So a single tool has broken this all down for you. But also for each solution, we'll now see the motion profile and the results, our acceleration, speed. We can then click through to our motor characteristics, start to look at data such as the root mean squared of torque and what the motor is actually performing at, and finally, the BOM. Now, this was a first draft. Now, let's go and fine tune some of these parameters. So you'll notice on the left-hand side, we've got some of the application parameters. The first step was a rough parameter list. Now we can fine tune that with options such as, do we wish to utilize a gearbox? Now, as you change this, and for instance, we've removed a gearbox, it updates the results live. So do we wish to use a servo motor for this? And when we select servo motor, we can then define parameters such as, do we wish to use a single turn or even a multi-turn encoder? We can further options such as axial parallel kits, the integration of a brake, and finally, all the other parameters such as the ambient temperature and define stuff like the cable length we wish to utilize. Once we've gone through all of these options and we've selected the exact parameters for our application in question, we can scroll back to our results. And again, we have the 3 solutions which are based on the most cost-effective solution for your application. Once we've defined these and we're happy with the results and the parameters that we've put in the top right-hand corner, shown here, we can download 2 separate files. The first of these is the application file, which will then give us the full sizing report for what we have sized in a PDF format. All the data we've put in for the application live in the tool, and all the motor and motion profile data, including the BOM, in a single file. This can be stored in your machine documentation. The second one is a commissioning file. Now, we spoke about earlier, one of the challenges was how we can easily parameterize a drive. We'll show you how we utilize this file later with all of that application data. And finally, once we've sized it, we can add all the components to the basket. That will give you price and availability straight away, but also on top of that, download all of our CAD files.
So thank you, John, for showing us how easy it is to dimension a complete servo system in our electric motion sizing software. Now, electric motion sizing is an online tool, so there is no need to install any software on your computer or on your PC. Online also means that you are always using the latest version of this software. It's always kept up to date by Festo. Now, Festo also pays a lot of attention to the connectivity of our components. Could you explain what this connectivity means for our customers and how our customers can benefit from this?
Of course I can. Connectivity is a really important topic for Festo. And the reason why is connectivity is all about how easy to use a solution can be. And we break connectivity up into 3 main areas. The first is mechanical connectivity, Then we talk about electrical and software connectivity, intelligent software, and finally machine control architecture, which is integration to your PLC. And the overview behind me here gives a real brief overview of this, which we'll refer back to later on. And this overview is for all Festo products, be it our servo controllers, extra low voltage servos, I/O, and PLCs. The mechanics are always at the base. And when we talk about mechanical connectivity, that's topics such as integration of motors to mechanics, brackets, etc., which we'll dive into in a bit. Then we talk about software, how easy it is to get the parameters into those products, how we can parameterize those and get the application data in. And final stage of connectivity is from your chosen PLC, be it a Festo Codesys-based controller, a Beckhoff, Rockwell, Siemens, whatever PLC it may be, how easy it is to control a Festo solution. So we'll start with mechanical connectivity. And the first step of this is to take a look at a typical XYZ handling solution. So we've got one here. And this is utilizing all Festo standard parts. There are no third-party components or special components in this. This means it's using our standardized tooth belt and mechanical axes. Homing sensors integrated directly into the mechanics. No longer do you need to design or utilize a third-party sensor, special brackets. They're all standard accessories. When joining an X and a Y axis, for instance here, they're utilizing the Festo standard mounting brackets. You don't need to design an interface bracket to connect the two mechanics together. And finally, the axial or parallel kits are all standard for the range of Festo servo motors, gearboxes, or even if you wanted to use our range of ultra low voltage servo motors. What does this provide? Well, it's reducing your design time, the associated costs, and any technical risks, knowing that the complete solution has been designed to seamlessly integrate together. The second step when we talk about connectivity is intelligent software. And we really talk about this in terms of the Festo automation suite. So if we cast our mind back a couple of slides, we had all the Festo product ranges there, from the servos, I/O, and extra low voltage servos. And when we talk about this, we have a single software which goes across the complete range. And typical, when we talk about connectivity, we talk about how easy it is to connect and get all your data in. So when you utilize this tool for any Festo servo drive or extra low voltage servo, which you connect, you can download all of the plugins, the firmware in the tool. No longer do you need to be searching through websites to find the right firmware or plugin. All the manuals are automatically within the tool. As soon as you've selected your device you wish to parameterize, all the manuals are there with links to the relevant documentation and the most up-to-date versions too. Servo drives are commissioned in less than 5 minutes. We've got an integrated wizard, step-by-step process of commissioning a servo drive. And finally, if you're going to utilize a Festo PLC with Codesys, Codesys is integrated to the tool. So when you start the process of commissioning a drive, all those parameters go directly into the Codesys environment too. When taken to this, it's reducing your complete time commissioning a solution, be it valve islands, I/O, servo drives, full solution in a single tool. And finally, the final stage of connectivity is machine control architecture. And when we talk about this again, it's control from the defined PLC to your servo drive in question. So for instance, we've got 3 different comms here, which our servo drives can be controlled by. So for instance, let's say if you're using a Siemens PLC with Profinet. Our CMMT servo drive can be controlled by ProfiDrive. So we can do point-to-point motion with application class 3, which is the sign and pos function blocks, or even interpolated motion with application class 4, the technology objects. So if you're familiar with utilizing a Siemens PLC and the ProfiDrive profile, our drives are controlled in exactly the same manner and your machine code is exactly the same. It's seamless. And then when we move to say EtherCAT, we utilize CIA 402. So for instance, Beckhoff, Omron, or any other PLC which utilizes EtherCAT with CIA 402, we can do point-to-point motion with the PLC open function blocks, or even interpolated motion with PLC open or NC axis. And the final option is Ethernet IP and Modbus TCP. With this, we can do point-to-point with the bespoke Festo motion blocks, which are all based on the PLC open blocks. So if you're familiar with utilizing these, then the control of those in these environments through a Rockwell PLC or any third-party PLC using Modbus TCP will be very familiar to you. Again, reducing time, cost, and any technical risks. You know how to control these, and you're familiar with the language and the profiles to drive the drives.
So in conclusion, we have different levels of connectivity. The first one is the mechanical connectivity, so meaning the assembly of the components. It's very easy to mount, for instance, our servo motors onto our electromechanical axis. Secondly, we have the electric connectivity, which means that, for instance, our servo motor can be easily connected to our servo drives, thanks to standardized cables. And finally, the intelligent connectivity, allowing our server drives to seamlessly integrate into your control architecture. And as a bonus, we have our Festo automation suite that makes this integration very, very smooth. Now, Josh, can you explain us how a traditional servo integration looks like and what is the bonus of our on one-step solution?
Perfect. So when we take a look at this, this is a traditional environment. So this is maybe how it's traditionally done. So for instance, behind me here, I have 3 different PLCs, which you may recognize. For instance here, and the PLC will have its own drive. So for instance, if we take the Rockwell PLC, the Rockwell controller, and associated motor. Now, when we're talking about special purpose machine builders, you may have machines which have various different PLCs which you need to utilize based on end user specification. So every machine that you design, which has a different PLC in, you have a different motor in it. These motors are not to a standard. So every time you need to take a look at the mechanical connectivity, and that's a message we spoke about earlier, you may need to look at how you redesign the brackets to suit and the axial kits, but also resize them because the inertia ratio may change. When we talk about electrical connectivity, we have different controllers. Every time you need to redesign your panel, all your wiring looms, energy chains because of different cable diameters. And finally, you're becoming familiar with different software. Each drive is configured and parameterized in a different environment. So we take a look at what Festo have now developed, and we call this a multi-protocol drive. So what we provide here is a single drive which can communicate with all the different PLCs. And when we say a single drive, there is one part number for each size class, which can communicate over Profinet, EtherCAT, and Ethernet IP/Modbus TCP in a single part. So what does this provide us? Well, when we talk about mechanical connectivity, with this, the motors remain the same, with the same motor, the same interface. From a mechanical perspective, if you're driven to different PLCs, your mechanical solution remains exactly the same. And so does the panel. The panel remains the same. There is no redesign necessary. All of this from a single drive, reducing your time in design and commissioning. So multi-protocol, what does this actually mean? Well, it actually means a single drive, as we said, controlled by multiple Ethernet protocols. So how do you switch between this is really driven by 3 different options which you can select. The first option is the drive is built in with auto detect. So when the telegrams are coming to the drive automatically knows which telegrams are being used, be it Profinet, EtherCAT, and automatically switch to it. We can also use our Festo automation suite, which we spoke about earlier. There'll be a video later on where I'll go through step by step, but we can set it in the parameterization file, or even dip switches. Here, we can take off the head of the unit, flick the dip switches, and set the field bus we wish to use. So this gives special purpose machine builders, for instance, absolute flexibility. You can have a single drive, irrespective of the PLC you need to use, and it will work with that PLC. Reduces all of your design time in both mechanical and electrical, and also programming too. And for both end users and machine builders, standardized spares. No longer do you need to keep local stock of different PLCs, different drives. You can have a single drive, and whichever comms is being used, you can send that to your end customer or local on site, flip a dip switch, and you've got a drive with the comms profile you require. Again, reducing time, cost, and all risk. So We've spoken quite a lot about our servo drive, so I think this is a great position to now maybe give you a brief overview of our drive. So here is our CMMT servo drive, and we'll start from the right-hand side. At the back of the unit, we've got an integrated braking resistor, which then connects straight at the top. In our electric motion sizing tool, we size this based on the braking resistor which is integrated to the drive. If this braking resistor isn't suitable for the application, then it will size a secondary braking resistor. So you can remove this, connect a new braking resistor. So in the single tool, we will size the braking resistor which is suitable for your application. It's got an integrated filter in the drive, so there's no need to buy a secondary integrated filter for your drives, but also we've got different motor connections. So we've got our EMMT, which is shown here with a single motor and encoder cable, but also we've got our EMMB, which has got independent motor and encoder cables plus a brake. So dependent on your application, we've got different motors which may be suitable. We can then move across to this side, and on the front of the unit, we've got a display. You don't need to use the display. It can be easily removed and also connected to the drive. And you only need one display, we don't even need them, for a bank of drives. This will give real text diagnostics, not an error code, not a flashing light. It will actually tell you the error. If you've got a following error, for example, have all your settings and parameters, but also backups. So traditionally, let's say if you need to replace a drive in the field, you may need to connect remotely to the drives to download the parameters to it, program your PLC to download the parameters to the drive, or even send an engineer to site. You can have all the data stored here. So then the end user can connect the display, download the parameters. We've got all the connections on the front and the top of the drive. So when you're wiring it into a panel, we know how challenging that can be when you've got them underneath, on top and in front. It makes it very, very easy and also space saving. And finally, we've got multiple encoder connections here. So you've got a flexible choice to utilize just a single encoder on the motor or even a secondary encoder. So let's say if you need real precision on a carriage, you can put a secondary encoder or even camming to it. And finally, we can do, because we've got flexible encoders, we can also connect third-party motors to it.
So we have now seen the hardware, but I would like to come back to the software, the Festo automation suite. Now, Josh, can you show us how easy it is to parameterize a servo drive, but starting from scratch?
Perfect. So to start this, I said earlier when we're doing electric motion sizing software that there was a single file, the parameterization file. So let's say the mechanical engineering team are designing this solution, they've got that file very stored at the end. Now, let's say this was then given to your programmers. So let's go step by step for how this would work. So in the first step here, we then have our file, our associated file. We open up the automation suite. We can then open up and select to import a file. So we select the imported file, we select the software we use. So for this, we use the electric motion sizing, and we can browse and find that file in question. So you remember this file from earlier, and then we can open the associated file. Once we've opened it, it will import this file directly into the automation suite software. And then from here, we spoke about earlier about how easy it was to get all the necessary data for the drive. For instance, documentation, function blocks, wiring diagrams, manuals. As I'm just showing here on the right-hand side, they're all readily available. So there's no hunting. Now, the next stage is we've got to open up this drive. So because it was sized in electric motion sizing software, it's now taking all of the parameters across to create your parameterization file. One of the challenges which you actually gave us feedback with regards to. And this takes about 20-25 seconds. This is a real-time example. Normally, in a traditional process, you would go step by step by saying, this is my servo controller, find the part numbers and enter in all these manually. As you'll see here, we've now pre-populated all of the details for the devices which were sized in the electric motion sizing software. So these are directly in, saving you a significant amount of time, but also error input. We know from a manual point of view, human error can come into play. Now I'm just going to start to parameterize this drive. We've got the application data in. Now let's change a couple of parameters. We can choose how, for instance, we wish to enable a drive, digital I/O, field bus, mixture of both, and also if we're using external braking resistor. These can all be defined. Then we can move down to our field bus selection. As I said, Autotech, dip switches, but also, as we're showing here, set by the Festo automation suite. We can set it here too. So we've defined our field bus, how we wish to actually enable the drive. Now let's take a look at the digital I/O. Do we want to have homing sensors coming into it? Touch probes, outputs, camming. We can define all these here. And finally, our encoders. So with these here, we can define all of our parameters, or if we're going to use a secondary encoder. We then move into the mechanics. So when you wish to control a drive, you also may wish to say how we wish to home it. So for instance here, we can home to a limit switch, positive or negative, but also to a hard stop, block, positive or negative. We can define these parameters quickly and easily by selecting the homing method we wish to use. We can then select what our axis 0 point is, so our software limits, and where we wish to move to for that offset. And finally, any homing parameters, so the speed at which we wish to home to, so we don't go crashing into the axis. And the final option is record tables. Quite often, drives will be controlled by direct mode. So from the PLC, you will stream your position, speed, and acceleration, so the complete motion profile, to the drive in question. But we've also got the option for a record table, as showing here. And with a record table, we can actually put in the motion profile we wish to utilize. So I'm going to put in 100 mil, for instance, and store this as a record within the drive. And we'll come back to this in a bit. And these are stored within the drive. Once you've got all the data in, we can take a look at the closed loop parameters. And here you'll notice that the application mass, 5.5 kilos. What the engineers have sized gets put directly into the drive. And then if there's any discrepancies, we can then also take a look at the closed loop parameters by fine tuning those. And we've also got auto tuning built into the drive. So brief look over some parameters that we can control. Now we can look at controlling the drive. By selecting the control drive from the Festo automation suite, we can home the drive, and a defined parameter, but also jog and move it and call off that record. So you don't need to control it via the PLC for application testing. And finally, we can then take a look at all of our diagnostics and perform auto tuning. But that's just a very brief overview of Festo automation suite, really showing you how in less than 5 minutes, and also using the electric motion sizing tool, we can size and parameterize a complete servo drive solution.
Now, the latest version of our CMMT servo drives is very compact with power ratings from 350 watts up to 6 kilowatt, and this will be further extended in the near future. And thanks to our multi-protocol technology, they can seamlessly integrate into most PLC environments. And thanks to our Festo automation suite, you can have a servo system up and running in just a few minutes, like shown by Josh.
Now we're going to move into our final poll question. So what we really want to know is what the main challenges that you would have in swapping to an alternative drive supplier. We're going to be talking about in a bit support that we provide in this journey. We've spoken about all the tools, now we need to move to support, but we want to get some of your feedback as to what the challenges are. We can really focus on some areas. So I'm going to hand over to Simon to start to run this poll.
Thanks, Josh. That poll's open for everybody. I can see people putting their answers in. Which of these do you see as the main challenges in swapping to an alternative servo drive supplier? So time to familiarize, existing PLC compatibility, training and support for engineers, new unknown software, or cost of software. So I'll just give everyone a few more seconds and we will take a look at the results. Okay, I think most people have entered their choices. Let's have a quick look at those results, Josh. Okay, so kind of two leading contenders here, Josh. The top one is time to familiarize, and the second one is training and support for engineers. I don't know, is that what you expected?
It is. It's going to be quite interesting when we show the next slides, because that's something which we get a lot of feedback. Time to familiarize. We know with these projects there are timescales, and sometimes the program or controls is at the very final step in the project, and they can have very short time spans to become familiar with the software. But also when we talk about training and support, When you've got the drive, what support's available from Festo? So that's really great feedback, and we'll focus a little bit more on this through the next steps.
Yeah, like we've just seen in the poll, support is a very, very important aspect when doing projects. Now, what support can Festo give to our customers with regards to servo drives,
Yep.
Josh?
Perfect question. So let's remove some of the headaches. So with this peace of mind, and we spoke about this going alongside underneath sizing, selection, building, and commissioning, we then talk about the peace of mind, the support that we provide. So there's a couple of different tools which we utilize. The first one is self-help videos. There's a whole YouTube channel called Service to See, and what we provide is step-by-step support, configuration, and commissioning. So for instance, I went through Festo Automation Suite, showing you very briefly how to import a file. There are a couple of videos on YouTube showing you exactly how to do that step by step in a slower, more stable format and what all the options are. For instance, if you've got a mechanical axis, a tooth belt, and you want to know how to retension a belt, change a belt, those are all available in YouTube as videos, nicely, easily digestible, and you can pause and stop them at any moment. Finally, application notes. This is a really important one. When we talk about time to familiarize yourself, this is one which we'll spend a little bit more time on. I think it's quite important, and we'll focus on this. And this is a how-to documents. So these can be done at the very concept, development of a solution, all the way to the very end, and we'll show you how these are used. And finally, we talk about support. We can then come into commissioning and on-site services. In the modern day, a lot of stuff is done remotely via TeamViewer, Teams, on-site, in person, email, phone calls. These services are all available, but we'll talk a little bit more about this in a second. So the one I want to spend a bit of time about is our application notes. So for instance here, I've got a couple of images that some of you may be very, very familiar with, which is from the Siemens TIA portal. And in our application notes, we do step-by-step how-to documents. So for instance, we will show from the Festo Automation Suite how to set the parameters up. So for Siemens, for Profinet, for instance, and the step-by-step of importing the GSDML file, parameterizing and commissioning it, then integrating the associated function blocks, such as this, the signer POS block, how you implement them, and also how they are controlled. But we don't just do this for one PLC provider. We do this for a variety of PLC providers via Profinet, Ethernet IP, and EtherCAT, step by step. So no matter which PLC that you have to integrate for a special purpose machine builder, there'll be an application note for you. And within those application notes, they're not just step by step. They also have projects inside them. So let's say time to familiarize is one of the things you gave us some feedback on. There's projects incorporated. So for instance, let's say Siemens. There will be a Siemens project in there which you can import and see how the drive is parameterized, commissioned, and all the associated function blocks, giving you slightly more time to familiarize yourself with the software and the environments that are utilized and controlled. Finally, we also spoke more about time to familiarize, support. Well, we have an application center in GB that you are more than welcome to bring your application to. For instance, if it's a pick and place handling application, bring it to our application engineers. We will test it. We will trial and work with you on the best solution for your application. We've got a connectivity workbench with all the main suppliers' PLCs, be it a Beckhoff, Siemens. You can connect these up, the Festo servo drives, or even our IO solutions to them and get familiar and familiarize yourself and de-risk it for that project. Spend that time to familiarize yourself with it, but also you're not alone. During our application support in our application center, our application engineers are there with you, hands-on. So before the project even starts in the initial design and concept phase, people are available to come to our application center, trial, test, familiarize ourselves with the tools and the software. We understand your challenges. That's why your feedback is no surprise to us, and that's why we've developed the application center.
So as you can see, Festo can provide you with the necessary support in every step of your project, and this via various channels. So you can start a new automation project with peace of mind. So this brings us almost to the end of this webinar. We've seen how our selection software enables the easy and reliable selection of servo systems, how connectivity on 3 hardware levels and on the software area simplifies the integration of these technologies into your existing machine architecture. And this will save you a lot of time, costs, and will eliminate risk. And you can, of course, always count on the support of Festo. So now is a fantastic time to change to our newest generation of servo drives, the CMMT-AS Multiprotocol. The Multiprotocol is 100% compatible with most of the PLC brands out there. So changing to an alternative servo drive doesn't have to be complex, time-consuming, expensive, or risky.
Okay, thank you very much, Josh and Johan, for that excellent presentation. That's the end of the main presentation today. Before we pick up any questions, just a reminder to everybody that you will get an email with a link to the recording of the session. If you still want to ask a question, please put it in the question block in the GoToWebinar menu. So just before I get to the questions, I'm sure you guys would appreciate a bit of feedback from everybody who's watching. So if you're watching the webinar, when you leave it, you'll get a little pop-up with a couple of questions. And if you could take just a minute or two to complete those, I'm sure Josh and Johan would really appreciate it. So let's go to the questions that have come in. The first one here is from Andrew. So Andrew has asked, can these systems interface with National Instruments DAQ? If so, which communication protocol do you recommend using?
Are you happy for me to? Yeah.
Normally, what we use is, in this case, Modbus.
Yep,
TCP,
Modbus TCP, yep.
But this has, of course, its limitations. It's not the fastest bus out there. So if you need interpolation and things like that, this is not the best solution. But it's just for point-to-point movements, and there our CMMT can generate these movements internally. Then this is a perfect solution. Mm-hmm. Can you comment on this?
Yeah, I'm quite familiar with using National Instruments for different projects. The thing about National Instruments is the function blocks that we utilize, what you'll need to do is manually map that. So Modbus TCP is the perfect bus system to use because it's open source, readily available to communicate to our drives. You'll just need to spend that little bit of time, utilize our application support engineers to understand that and that support to make sure you map all the IO correctly to control the drives.
Okay, thank you. Hope that's okay, Andrew. A couple of questions from Edward. So first one is, can you control your drive by a PLC using only the record table from Automation Suite?
Would you like me? Yep, no, fine. That's absolutely fine. You can do that over any of the bus systems. You can do that for the record table. So you can have a number of records stored, so all the records you'd like to use, store those step by step. And basically the only difference is rather than streaming from the PLC, your defined position, speed, and acceleration, you just call off a record. So for instance, record number 2. You do record number 2, you then get a motion complete. I've completed the record, you get the feedback, you can then call off your next record. So it's very easy to do, and you can do a whole machine via that method. It's your choice how you'd like to control the drives.
Okay, and a second question from Edward. Where can I find the function blocks, for example, using a Siemens PLC to control a drive?
Okay.
So where can you find the function blocks?
So if you're familiar with the Festo online website, if you put in the Festo servo drive, for instance, the CMMT, which we're talking about here, that will then bring up a single page. And in there, underneath CMP, you'll see where there's a source for downloads and the documents. In that page, because it's on a single page, there's no different pages, you'll see all our application notes there and all software and downloads. So you'll be able to download our Festo Automation Suite, but also all the function blocks and the application notes in a single area. So all you need to do is put in CMMT, our servo drive family, and then you'll be able to find all that data on the website. If you're unsure, then you've got our contact details here, or call the Festo mainline number, and we can talk you through it.
Okay, thank you. Next question, how many CMMTs can you link cross-wiring together?
Ooh.
Do you mean by DC bus, I suppose? So then there's a limit. This depends on the power of the servo drives used. It's in our documentation. From the smallest one, it's, I think, 8 units that you can link, but you need to take care of the protection of the wiring. So you need to provide a fuse at the beginning to protect the wiring across the different drives. but it's a very good solution when you have drives decelerating a mass, so you can store this energy in the other drives to accelerate other movements. So this is a very good solution, and it's perfectly possible with the CMMT-AS.
I can only assume when it's talking about linking, it's DC link, or it may be linking the drives over the protocol, but I would assume it's DC link.
I assume, yeah.
Okay, good. Next question. Can the drive auto-detect and auto-parameterize the connected third-party motor?
Okay, would you like me to?
Go ahead. Yeah.
So, for instance, if you already know the parameters of your servo drive, and let's say you have it connected, you can have all the parameters stored on the drive. So if we're talking about if we replace a drive on it, we can store all the parameters on the display in the PLC and have this stream to it. If it is the first time, you need to set up the parameters for that drive into the controller. So you'll need to set, obviously, for instance, define the encoder, number of pole pairs, etc. All the parameters of the servo motor will be commissioned or parameterized within the drive. That would need to be manually done. For all the Festo servo motors, you select the part number, it's all there, preset, done. But if it's a third-party motor, you'll need the technical information for that motor, and we'll need to cross-check that the encoder output matches our drive, but then it's just manually done. Do you have anything to add, Johan? Or
Yeah, that's quite correct. In our motors, we have a memory storage, so you can read the data from the motor into our CMMT-AS. This is a new functionality we will add. But the project we are doing, we are calculating a complete system, so the mechanics, motor, gear, etc. And this means that you have all the parameters necessary to perfectly parameterize the servo drive. If you only have the data of the motor, this is not enough to parameterize the servo drive. Then you still need to add mechanics, gearbox, etc., etc. So we are doing another approach with our Festo complete system.
Okay, a couple of questions from Lewis. How is the availability of the servo motors and drives? I guess that's a question we were expecting, guys.
Yep. Would you like me to say that, Johan? Perfect. So in terms of motors, cables, readily available, but like the current market, everyone's well aware of the availability of raw materials, especially in electronic components. Festo was challenged by that as well when it comes to the servo controllers. So when the challenges first hit, and when the availability of raw materials was impacting production, Festo actually took this as an opportunity for us. And that's one of the reasons that we developed the CMMT Multiprotocol. We moved the chipsets to a more readily available chipset, which also gave us all these new functionality, which we could enable. So we saw the opportunity, we developed the CMMT Multiprotocol. What that's enabled us to do is increase production fourfold. We've actually created more drives this year than we had of any previous year. But as we know in the current environment and the supply of raw materials, that some of our competitors are impacted by the supply chain, and that increases demand on us. So it's very, very hard for us to even confirm a defined lead time. What I would suggest is we take this by case, the project basis, understand what your needs are for it, and then we can discuss it in further detail. It's very hard to give a one-size-fits-all answer.
Okay, thanks, Josh. Lewis had a follow-up question as well. Can you change the speed? Can you change the speed acceleration on the fly when the machine is moving?
That's not a problem. Yeah, of course, if you are using continuous mode, so when you're always sending a set point from the PLC or the motion controller to the drive, this is automatically. But also when you're using point-to-point mode, so when the drive is generating the profile, you can always switch over to another profile and then the drive will accelerate or decelerate. That's not a problem. This is possible.
Okay. Question from Yannick. Can we use the Festo servo drives with Siemens servo motors?
I'm assuming that's very similar to the previous question, if I've understood correctly. So when you talk about the Siemens servo motors and the Festo servo drives, very, very similar to the previous question about defining it. So let's say, for instance, you've got a Siemens motor and a Festo drive. All we need to know is the parameters for that Siemens drive. Very, very similar answer. To just confirm that, we need the data sheet, send that to Festo technical support. We will confirm it, and the process is exactly the same. If it all makes sense, but as Johan said earlier, it's great to do that, but then from a connectivity point of view, utilizing a Festo motor or a Siemens motor, it's probably easier to use a Festo motor for all new sizings, etc.
Yeah, the main aspect in this is that the encoder is compatible with the CMMT-AS. So it depends on the Siemens motor. Is it an N.2.1, 2.2, or Nikon, or whatever they are using in their motor? Then we can adapt always our CMMT-AS drive to the characteristics of the motor. But the connection between the encoder and the drive, that needs to be 100% perfect, as it is a servo system.
Okay. Quick question from Carol. Can you add a control record from the PLC?
Don't quite understand.
I'm not quite sure on the question. Maybe some of Carl's able to add some more information, or if not, what I'd say is we can take that question offline.
We'll get back to you on that, Carol. Last couple of questions. Replacing a drive out, how to send the parameters of the drive and motor to the new drive. Can this be done via the PLC, or do you need to reload the XML file manually?
So there's a couple of different options here. First one is you can have all the parameters stored in the drive. So you can stream the parameters direct to the drive, but also, as said earlier, we've got the displays here. So if you include one display in your project, all the parameters are stored in the display. So for instance, drive fails, you fit in the new drive, all the connections, you put them in, turn the power on, connect the display, go to the right parameters, you select these to be downloaded to the drive, done. All your parameters are there. So you don't need to do all the PLC programming to download all the parameters to the drive, set them in the display. There's plenty of different options, or connect over Automation Suite and download them.
Okay, coming to the last couple of questions. Johan, you might have already covered this. What's the largest size drive available?
At the moment, it's 6 kilowatts, and it will in the near future be extended. We will have 9 and 12 kilowatts available.
Okay, and David has asked, can PID control be done within the drive?
Yeah, we have not PID, but PIMP control. So there are always 3 levels of control in a servo drive for positioning. So the first one is the current controller. This is a PI controller. Then you have the speed controller, which is around it. This is also PI controller. And then finally, you have the position control, which is a simple P controller. So this is always included. If you want to use an external control loop to do a special movement or a special application, then this PI or PID loop should run in the PLC, and this should send on a continuous base every couple of milliseconds a new set point to the drive. So then you have the PI control in the drives for the movement itself, and then you have an external PI or PID controller for whatever application you want to do with it. But it's possible. We are time-based, so every couple of milliseconds we can receive a new set point for speed or torque or position. That's not a problem.
Okay, I hope that answers your question, David. So just final 2 questions before we wrap up. Martin has asked, what options for IO Link do we have?
Do you want me to say that, Johan? Perfect. So if we cast our memory back, and I know that was probably about 50 minutes ago now, to when I was giving the overview of the Festo in terms of connectivity, and we had a variety of different drives. So at Festo, we do servo drives, extra low voltage servo, and what we call simplified motion. And what simplified motion is it's point to point and an intermediate position of a stepper motor with the controller integrated to it. So because of the speed of IO Link's primarily utilized in terms of comms for Festo on simplified motion, so we can have simplified point to point and intermediate positions, and on our extra low voltage servos or stepper controllers, so servo control for a stepper. They're not traditionally used for our servo controllers because of the speed of comms. So when we're doing interpolated motion and we've got update times of 2 milliseconds, it's not fast enough bus system for that. So primarily point-to-point extra low voltage servos, we'd utilize IO Link.
Okay, guys, I think that's the end of the questions that have come in. So thanks very much for taking the time to answer those. We still have quite a few people watching, so You've got the contact details for Josh and Johan on the screen. If anyone has any further questions or follow-up questions, please feel free to contact these guys directly. Other than that, I think we'll wrap up the session and say thank you very much to our presenters and for everybody attending, and have a great day.
Cheers,
Thanks a lot.
Thank you for your time.
Bye-bye, everybody.